the requirement for an engineer's stamp on the electrical load calculation appears unjustified. Licensed electricians, including journeymen and master electricians, are tested on and expected to be proficient in performing load calculations. Their licensing demonstrates competency in these areas. In this scenario, the electrician is a master electrician with multiple successful tests reinforcing their expertise. The inspector previously worked with the electrician, potentially introducing bias into the situation. Demanding an engineer's stamp can create unnecessary costs and delays. The electrician should first discuss their qualifications with the inspector, explaining why a stamp is unnecessary. If the inspector remains unconvinced, seeking a second opinion from another inspector or contacting the local electrical code enforcement authority or the state licensing board may be warranted. Now let's discuss in detail the reasons why this requirement may be unjustified. Firstly, licensing and testing of electricians. Electricians undergo rigorous training and testing to obtain their licenses. These exams cover a wide range of electrical principles, including load calculations. A licensed electrician's ability to pass these exams demonstrates their competence in performing these calculations accurately. Secondly, the expertise of the electrician. A master electrician possesses a higher level of knowledge and experience than a journeyman electrician. Successfully passing multiple licensing exams signifies their deep understanding of electrical systems and their ability to perform complex calculations. Their expertise should generally be sufficient for standard residential load calculations. Thirdly, consider any potential bias or conflict of interest. If the inspector previously worked with the electrician, there might be a personal bias influencing their decision. It's important for inspectors to maintain impartiality and avoid any appearance of favoritism or prejudice. Fourthly, the cost and delay associated with obtaining an engineer's stamp. Engaging a professional engineer to review and stamp a load calculation can be expensive and time-consuming. This adds an unnecessary burden on the homeowner and delays the project's completion. Unless there are specific circumstances or complexities that warrant an engineer's involvement, the cost and delay are generally not justified. Now let us consider recommended courses of action. If the inspector is demanding an engineer's stamp, the electrician should firstly communicate with the inspector to understand the specific reasons for their request. Open and respectful communication can often resolve misunderstandings and address concerns. Secondly, the electrician should present their qualifications and experience to the inspector, highlighting their expertise in performing load calculations. Providing evidence of their successful completion of licensing exams and previous projects can help demonstrate their competence. Thirdly, if the inspector remains unconvinced, the electrician should consider seeking a second opinion from another qualified inspector. A fresh perspective from an independent inspector can help determine whether the engineer's stamp is truly necessary. Fourthly, if all else fails, the electrician should contact the local electrical code enforcement authority or state licensing board to inquire about the inspector's justification for requiring an engineer's stamp. These authorities can provide guidance and clarification on the relevant codes and regulations. Let's delve into how to perform a load calculation according to the National Electrical Code, or NEC. This will help illustrate the electrician's proficiency. Load calculations are performed in accordance with Article 220 of the NEC. The goal of a load calculation is to determine the minimum size of the service entrance conductors, overcurrent protection, and other components of the electrical system. The first step in performing a load calculation is to determine the general lighting load. For dwelling units, the general lighting load is calculated based on the square footage of the dwelling. According to NEC Table 220.12, a unit load of 3 volt amps per square foot is used for general lighting in dwelling units. To calculate the general lighting load, multiply the square footage of the dwelling by 3 volt amps per square foot. For example, a 2,000 square foot dwelling would have a general lighting load of 6,000 volt amps. The second step is to determine the small appliance and laundry loads. According to NEC 220.52 ONB, A minimum of two 20-amp small appliance branch circuits and one 20-amp laundry branch circuit are required in dwelling units. Each of these circuits is considered to have a load of 1500 volt amps. Therefore, the total small appliance and laundry load is 4500 volt amps. The third step is to determine the appliance loads. This includes the loads of all fixed appliances, such as ranges, ovens, cooktops, dishwashers, disposals, water heaters, clothes dryers, and air conditioners. The nameplate rating of each appliance is used to determine its load. For ranges, NEC Table 220.55 provides demand factors that can be used to reduce the calculated load. For example, a range with a nameplate rating of 12 kilowatts can be calculated at 8 kilowatts using the demand factors in Table 220.55. For clothes dryers, a load of 5000 volt amps is typically used, according to NEC 220.54. For air conditioners, the nameplate rating of the unit is used to determine its load. If the air conditioner is a central air conditioner, the load is calculated at 100% of the nameplate rating. If the air conditioner is a window unit, the load is calculated at 125% of the nameplate rating, according to NEC 440.62. The fourth step is to determine the heating load. This includes the loads of all heating equipment, such as furnaces, heat pumps, and electric baseboard heaters. The nameplate rating of each piece of equipment is used to determine its load. For heat pumps, both the heating and cooling loads must be considered. The larger of the two loads is used in the load calculation. For electric baseboard heaters, the load is calculated at 100% of the nameplate rating. The fifth step is to apply demand factors. Demand factors are used to reduce the calculated load based on the assumption that not all of the loads will be operating at the same time. NEC 220.42 allows a demand factor of 75% to be applied to that portion of the general lighting load that exceeds 3 volt amps per square foot. NEC 220.53 allows a demand factor of 75% to be applied to the loads of 4 or more fixed appliances, excluding ranges, clothes dryers, air conditioners, and heating equipment. The sixth step is to calculate the total connected load. This is the sum of all of the individual loads after applying any applicable demand factors. The seventh step is to calculate the service entrance conductor size. The service entrance conductors must be sized to carry the total connected load, according to NEC 310.15. The ampacity of the conductors must be equal to or greater than the total connected load. The eighth step is to select the overcurrent protection. The overcurrent protection must be sized to protect the service entrance conductors according to NEC 240.4. The ampacity of the overcurrent protection must be equal to or less than the ampacity of the conductors. Let's go through a sample load calculation. Assume a 2000 square foot dwelling with the following loads. General lighting load 2000 square feet times 3 volt amps per square foot equals 6000 volt amps. Small appliance and laundry loads 4500 volt amps. Range 12 kilowatts or 12,000 volt amps. Dishwasher 1.5 kilowatts or 1500 volt amps. Water heater 4.5 kilowatts or 4500 volt amps. Clothes dryer 5000 volt amps. Air conditioner 3 kilowatts or 3000 volt amps. Electric baseboard heaters 6 kilowatts or 6000 volt amps. The total general lighting load is 6000 volt amps. The total small appliance and laundry load is 4500 volt amps. The range load is 8000 volt amps after applying the demand factors in NEC Table 220.55. The dishwasher load is 1500 volt amps. The water heater load is 4500 volt amps. The clothes dryer load is 5000 volt amps. The air conditioner load is 3000 volt amps. The electric baseboard heater load is 6000 volt amps. The total connected load is 6000 plus 4500 plus 8000 plus 1500 plus 4500 plus 5000 plus 3000 plus 6000 equals 38500 volt amps. To calculate the service entrance conductor size, divide the total connected load by the voltage. Assuming a 240 volt service, the current is 38,500 volt amps divided by 240 volts equals 160.4 amps. According to NEC Table 310.15b16, a 1/0 American wire gauge copper conductor with a temperature rating of 75 degrees Celsius has an ampacity of 150 amps. Therefore, a 1/0 American wire gauge copper conductor would be sufficient for the service. To select the overcurrent protection, choose a breaker or fuse with an ampacity equal to or less than the ampacity of the conductors. In this case, a 150 amp breaker or fuse would be appropriate. In summary, performing load calculations involves several steps, including determining general lighting, small appliance, laundry, and appliance loads, applying demand factors, and calculating the total connected load. Electricians are trained to perform these calculations accurately and in accordance with the NEC. NEC Article 220 provides detailed guidelines for calculating branch circuit, feeder, and service loads. Understanding and applying these guidelines is essential for ensuring the safety and reliability of electrical systems. For dwelling units, the general lighting load is determined based on the square footage, as previously discussed. NEC 220.52 and B specify the requirements for small appliance and laundry branch circuits. These circuits are essential for providing power to common household appliances. NEC 220.53 allows demand factors to be applied to certain appliance loads, recognizing that not all appliances will operate simultaneously. NEC 220.54 provides specific requirements for calculating the load of electric clothes dryers. NEC 220.55 offers demand factors for household ranges and ovens, taking into account the diversity of cooking habits. NEC 220.61 outlines the procedure for calculating the optional method for dwelling units. This method can simplify the load calculation process for certain types of residences. NEC 310.15 provides guidance on selecting the appropriate conductor size based on the calculated load and other factors. NEC 240.4 specifies the requirements for overcurrent protection, ensuring that conductors are protected from overloads and short circuits. NEC Table 220.12 provides unit loads for various occupancies, including dwelling units. NEC Table 220.42 allows a demand factor for general lighting in dwelling units. NEC Table 220.55 provides demand factors for household ranges and ovens. Accurately applying these code requirements ensures a safe and code-compliant electrical installation. The load calculation should include all loads, including lighting, receptacles, appliances, and heating and cooling equipment. Each load should be calculated according to the applicable NEC requirements. Demand factors can be applied to reduce the calculated load, but only when permitted by the NEC. The service entrance conductors and overcurrent protection must be sized to carry the calculated load, taking into account any applicable demand factors. The load calculation should be documented and kept on file for future reference. This documentation can be helpful for troubleshooting electrical problems or making future modifications to the electrical system. An accurate load calculation is essential for ensuring the safety and reliability of an electrical system. Ignoring or improperly performing load calculations can result in overloaded circuits, overheating conductors, and potential fire hazards. Consulting with a qualified electrician is always recommended to ensure that load calculations are performed correctly and that the electrical system is installed in accordance with the NEC. In conclusion, while an engineer's stamp may be required in certain situations, such as for complex commercial or industrial installations, it is generally not necessary for standard residential load calculations performed by a licensed and experienced electrician. Understanding the relevant codes and regulations, communicating effectively with inspectors, and seeking second opinions when necessary can help resolve disputes and ensure that electrical work is performed safely and in compliance with the NEC.